Recently, I did a video on retained messages and I made a reference to persistent sessions. So I thought I'd make a video on that as well. So in this video, we'll go through what is a persistent session. We'll do a demo and we'll also take a look at a few considerations if you're going to be using this in your application. Great, so let's get started. For the introduction, I thought I'll just start from the documentation. So persistent sessions store a client subscriptions and messages with a QoS of 1 that have not been acknowledged by the client. So if you're aware with QoS 1, let's say there is a publisher sending a message to the broker, right? So when the message is sent to the broker has to send an ACK back to the publisher, letting it know that it has received that message. Similarly, if there is a subscriber subscribing with QoS 1, when the broker sends a message to the subscriber has to send an ACK back. Now, this is where persistent sessions comes in play. So if the subscriber has not sent back an ACK, the broker will store those messages for that client to send it to it when it reconnects. So when a disconnected device reconnects to a persistent session, the session resumes, subscriptions are reinstated, and the subscribed message received prior to the reconnection that have not been acknowledged are sent to the client. So when it reconnects back, subscribes again to those same topics with QoS 1, the messages which were unacknowledged and stored in the broker will be sent to the client, right? You can create an MQTT session by sending a connect message and setting the clean session flag to 0. Now we can see this in the code sample here. So let's go to the Python SDK sample. I'll go to the pub sub sample, and if I search for clean session, I'll actually find that here. So in this pub sub sample, they are setting the value to false, which means 0, right? So if I go into the documentation, it says that if you set the value for clean session to false, it will request the server to resume an existing session or start a new session that may be resumed after a connection loss. Great. One more thing to note here is that after a reconnection, the stored messages are sent to the client at a rate of 10 stored messages per second, along with any current message traffic until the publish requests per second per connection limit is reached. That means the moment the connection is re-established, the moment the client subscribes to that topic, the messages that were stored by the broker will be sent 10 messages per second, right? And now also if on that same topic, if there are multiple messages being sent along with that, they will also be sent to the device until you reach the publish limit. And these limits are adjustable, so not a problem. Great, so that out of the way, let's move forward with the demo. For the demo, we need essentially two pieces of code. One, a publisher that will publish messages to a topic, and a subscriber that will, one, connect with a clean session flag set to false and subscribe with QoS 1. For the code sample, I looked at the AWS samples and found the pieces of code for subscribe as well as publish. I also looked at this KC article, which has a sample piece of code for publishing to AWS IoT Core. Putting everything together, essentially we have two pieces of code. The first one is a publisher and the next a subscriber. The publisher will publish a message on this topic every 2 seconds. So I have a while loop running and it will send a message to this topic every 2 seconds. The subscriber is also subscribing to that same topic, connecting with the clean session flag as false and also subscribing with a QoS level of 1. So let's run these both. I'll run the publisher first so that it'll start publishing messages regularly on that topic. So here you can see it's gonna start iterating over this value. Okay, and let's subscribe to that topic. Right here, I'm getting 7, 8. So this is when I started. And let's let it run for a second. Now what I'll do is I'll unsubscribe and close the subscriber. Let's note at what point it's going to be closed, right? So I closed it at 15, but it's now going still on, right? It's going to 16, 17. Let it reach 20. Great. So I'll run this code again and subscribe. So now you can see, right? I stopped at 15 and now I'll get all the messages. So I should be getting 16, 17, 18, 19, 20, and then 21, 22, 23, 24, just like that. So the order is not guaranteed by AWS IoT, but you still get all of the messages that you missed out on, right? So let me just demonstrate this again. So the latest one is going to be 36. I'll let it run for a few seconds. And same thing happens. So we left it at 36. We'll get 37, 38, 39, 40, 41, 42, and then on. So this is mostly happening because we are still publishing to that same topic, right? So it is actually adding messages along with the persistent session, sending messages to the subscriber. Now that we're done with the demos, let's go back to the documentation and take a look at a few considerations. So the first thing we'll take a look at is, when does a persistent session end? So here it says that when the persistent session expiration time elapses. So down below it says the default persistent session expiration time is 1 hour. And this time will begin after the broker detects that a client has been disconnected, right? Now this value can be increased by raising a limit increase request. Also, whenever a client, let's say, connects with a clean session flag as 1, that means true, then also this persistent session will be destroyed. One thing to note, the connection timing out that they're mentioning over here actually refers to the keep alive time. So when a client connects to the IoT broker, it uses the keep alive timer to let the broker know that after this period of time, it will be sending an MQTT ping. Now, let's say a client loses internet connectivity, right? In that case, for that keep alive period, it won't be sending the MQTT ping. And once the timer runs out, the broker will manually disconnect that client, and that clean session timer will start from that point onwards. Lastly, we also have to take a look at pricing. So when an offline device with a persistent session reconnects and resumes its session, the stored messages are delivered to the device and charged to your account again. That means you will be charged twice for those messages that are being delivered from the persistent session store. Thank you so much for watching, and get subscribed for more videos.